Okay guys, and welcome back. So in this video we are going to be looking at the magnitude of vectors. My name is George B. Smith. Okay, so now when we talk about magnitude of vectors, what we basically mean here is this. We're looking at, just picture it as a length that's going to be occupied by a vector. Okay, let's picture that as the magnitude of a vector. For example, let's say you have a vector on the xy plane. This is the x, this is the y plane, and this is the x plane. This is, you have a vector, let's say the vector is at this point, okay, which means from here to here the vector is having, let's say, a magnitude of 3. From here to here the vector is having a magnitude of 5. Then you're asked, if this vector is here, what is the length of this vector? This is the x component, this is the y component. That means if this vector is a or the vector is b, this vector we have here is basically expressed in the form 3i plus 4j. It doesn't have a z component, we have only the x and the y component. So we have 3i plus 4j. That's why you have on the x-axis you have 3, on the y-axis you have 4. So now this is where the vector is, because that is where 4 meets 3. Okay, so now the question becomes, what is the magnitude of this vector? That means what is the length of this vector from the origin? I mean, if I take from this point to this point, what is the length I have here? That's what they're asking you, and that's what we basically mean by the magnitude of a vector. Now for you to look for the length of this vector, you agree with me that here you have to use Pythagoras theorem. From here to here is 3, from here to here is 4. Then when you use Pythagoras theorem, you can easily get the length of this, which is going to be the square root of 3 squared plus 4 squared. But to make it all simple, this is what we are saying. You have this vector. Okay, here you have 3 components. You have the x, y, and the z components, and you want to look for the magnitude. That's the symbol we use. We use this pipe symbol. We put the vector between this pipe symbol. You call that the magnitude. So the magnitude is, you pick the x component, you square it. Pick the y component, you square it. Pick the z component. That's what we're doing here. So you can see this is the x component, you square the x component. We square the y component, we also square the z component. Okay, so as a simple example, let's say I have the vector a, and then the vector a is having a value of 2i minus 3j, okay, plus 6k, and I'm asked to find the magnitude of this vector. So for me to find the magnitude of this vector, all I need to do is, okay, the magnitude of a is equal to the square root. So I have the root symbol. I'll pick 2, square 2. I will pick minus 3 and square minus 3, and then I'll pick 6 and then square 6. That is the magnitude of the vector. So when you work on each of these, this is going to give you the square roots. 2 square will give us a 4, minus 3 square will give us a 9, right? And then 6 square will give us 36, if I'm not mistaken. So add everything up, you have, this is going to give us 40, and that's square root of 49. And luckily for us, the square root of 49 is equal to 7, but we are going to say this is 7 units, because this is physics, this is science. Everything you deal with has to have a unit. So we say that is equal to 7 units. So that's the magnitude of this vector, 2i minus 3j plus 6k. Let's see another example. I have a vector. Let's say the vector is a, and a is having a value of minus 3i plus 6j, okay, minus 4k, and I'm asked to find the magnitude of this vector. So I'll say the magnitude of this vector is, I'll wrap this within the pipe symbol, is going to be minus 3 squared. So I have minus 3 all squared. I have 6j, but now it's going to be 6 squared. Then I have minus 4k, this is k, sorry, not I, this is k. So plus 4k, that will become minus 4 all squared. Now take note, whenever you square a number, the minus sign goes. So after you work on all of this, this is going to give you a 9 this will give you 36, right? And this is going to give us 16. So we add this up, this 2 will give us 45. Okay, 45, that's 55, 61. I think I'm right. Yeah, that's 61. So this is going to be the square root of all of this. So I have a square root covering this, I have a square root covering this, and I also have the square root covering this. So the square root of 61 is approximately going to give you 7 point something, 7 point blah blah blah. So you're going to get a value there. So that will be the result, and then you put units. So it is expressed in terms of units because we don't know what we're actually dealing with, if it's force or whatever. So that's how you find the magnitude of a vector. So that's where we're going to end this video, guys, and in the next video we are going to be looking at different operations on vectors. Okay, that's what we are going to be looking at from the next video. So I'll see you guys in the next video. Bye bye.